G'day team, welcome back to another video on differential calculus, and today we're going to look at the derivatives of trigonometric functions. So when we've got our basic functions sine x, cos x, tan x, it's nice and easy when we've got that because we don't have to do anything extra. All we have to do is flip sine x to cos x in the derivative. Cos x goes to negative sine x and tan x goes to 1 over cos squared of x. It gets a little bit trickier when the inside of my sine is a function, but the only thing we have to consider is the derivative of the inside, and we multiply it by the original function just with our little sine to cos, cos to negative sine, and tan to cos squared x. Now, we're not going to harp on too much about that. I'll show you a few examples so you can get a bit of an idea behind that. So I've got 4 examples here. Let's focus on this first one to start with. So find dy by dx if y equals sine of 4x plus 2. Now we can see we don't just have x, we've got 4x plus 2. So to find, when we first start finding the derivative, and I'll do in black, dy by dx, we have to find the derivative of the inside of my sine function. So that would just be 4. Now that comes out the front and multiplies, and we know sine goes to positive cos. So cos, and we rewrite the inside of my original function. And that's it, that's all we have to do. So derivative of the inside, change the trig function to the one that's necessary, and rewrite the inside. So let's have a look at part B. Now part B, we can see we've got 2 functions of x multiplied together. So that means we're gonna have to use the product rule. So let's identify u, which is negative x, v, which is cos x. We all know u dash goes to negative 1, and v dash, now because x is just, well, cos of x is just x on the inside, we can just replace it with negative sine of x. Now my product rule, we all know, is u dash v by plus u v dash. So u dash v is negative cos x. Then I've got negative x times negative sine, which gives me a positive x sine of x, okay? And that's it, that's how we can leave it there. Another example, so just a reminder of notation, this cubed in between the cos and the 3x squared just means my whole function is cubed, so y equals cos of 3x squared, all in brackets cubed, which means I can apply my chain rule. So 3 will come out the front in my derivative, so dy by dx. 3 comes out the front. I rewrite all of the inside, so cos of 3x squared, and then I drop my power by 2. But I'm not quite done yet. I need to multiply by the derivative of the inside of my square, which is cos of 3x squared. Now to do that, we need to find the derivative of the inside of the cos. So that is going to be 6x, so times 6x. Now, cos goes to negative sine, so I'm going to put a negative out the front and change it to sine, and I rewrite the inside there. Now, we're going to leave it like that, but we can simplify it by multiplying the 3 by the negative 6. But because we're not simplifying, we're just going to leave it in that form there. All right, let's do one more example. So I've got the natural log of x squared times sine of x squared inside my log. So in this case, we could product rule this and then go from there. But with our log, it's much easier if we split up using our log laws. So I've got the natural log of x squared plus the natural log of sine x squared. And we know from the past video that the derivative of a natural log is the derivative of the inside divided by the original function. So dy by dx equals 2x over x squared. Now, because these are separated by a plus, I can do them individually. The derivative of sine x squared is 2x cos of x squared. So that is the derivative of the inside at the front, change the sign to a positive cos and rewrite the internal of the cosine and rewrite my original function. And there we have it. So hopefully there's some good examples there for you to now have a go at some questions. Thank you for watching, and we'll see you in the next video.